welcome. Today we're going to be going over the test review. Now, yesterday I put up a video that was assignment number 11, and the page said 12, but it's still a good video review as far as how to do half angles and double angles. Now, this one combines them all. You have some difference in double angles. So let's go ahead and get started. It says right here, use information given about the angles alpha and beta to find the exact value of sine alpha minus beta, cosine alpha plus beta, tangent alpha minus beta. Now, first thing we got to do is get started is that these are properties require us to actually find out all three values. So like with this one, I'm missing tan alpha, and I'm also missing cosine alpha. So this is opposite over adjacent. This is adjacent over hypotenuse. And what I am given, I'm given sine. Sine has been given to me as, in this case, alpha is opposite over hypotenuse, which means that in this I'm given 12 over 13, which means that I have opposite and hypotenuse. Automatically I could say that this is 12, and automatically I could say that this is 13. What I'm missing is the adjacent part of this. So with that, in order for me to find the adjacent part, I have to use the triangle is basically the unit circle, because I'm going to draw the unit circle now. And I'm going to find where pi is at. Pi is right here. This is pi. And I'm also going to find pi divided by 2, which is here. Which means that my angle, I'm going to be focusing on this quadrant right here in order for me to go ahead and get an answer. This is where my quadrant's at. Now, one thing to keep in mind, this quadrant is positive in the cosine. Well, actually, no, the other way around. Negative with the cosine, positive with the sine. So x is going to be, so when I draw my triangle with this one, okay, this part is going to be positive, this part right here is going to be negative. And the reason why that's important is because I'm given opposites, so 12, 13. When I find out my answer, the answer here, whatever it's going to be, needs to be in negative. Okay, what I mean is negative. Negative as far as the value. So let's go ahead and actually find out what that answer is. And I'm going to do that by applying Pythagorean theorem. So I'm going to go ahead and actually write down leg squared plus leg squared is equal to hypotenuse squared. I'll get 144 plus b squared is equal to 169. Subtract 144 to both sides. I'll end up getting that this crosses out. I'll get b squared is equal to 25. And when I take the square root of that, I find out that b is actually equal to 5. So that means that in this case, my adjacent side, well, one thing I did left out, I wanted to make sure that was important. This is plus or minus. We said that that side is negative, so that's going to be a negative 5 that goes here. This is going to be, without a doubt, negative 5. The reason why that's so important is that when we fill these in, negative 5, negative 5. So I have my three values, here, here, and here. Three values are done. Now, I have to now do the same thing with the tangent beta. So I'm going to go ahead and kind of draw a line to separate both. I'll switch colors to really define what is it that we're doing. Because see, the thing is that we have tangent beta is opposite over adjacent. And in this case, you'll have, one of these is going to be negative. Don't know which one yet. But I also have to find sine beta, which is opposite over hypotenuse. I already have opposite side. In this case, it's going to be negative 1. And I'll show you why it's negative 1. I don't know what hypotenuse is at, and I do have cosine beta. Cosine beta is adjacent over hypotenuse. And in this case, I have adjacent, which is 2. It's going to be positive, though. What I'm missing is a hypotenuse on this one. Now, let me draw the triangle so y'all get a clear idea. How is it that I figure out this is negative 1? When we draw the triangle and we identify 3 pi divided by 2 being at this side of the unit circle, and the 2 pi is here, we find that our measure of focus is going to be here. So a quadrant. Okay, and once we establish the quadrant, we go back and establish our angle. This is how I identify, because remember, we have an opposite over adjacent. This side, this triangle, we have positive, negative, which means that this right here is a positive 2, This is the negative 1. And that's how I was able to achieve a distinguishing where the negative belong. Now, what I still need to do is find out what the hypotenuse is. So for that, I'm going to use Pythagorean theorem. 2 squared plus negative 1 squared is equal to c squared. This being c in this case. I'll get 4 plus 5. Oops, not 4 plus 5. 4 plus 1. I jumped ahead myself because I'm already adding in my brain. C squared, and I end up getting 5 is equal to c squared. Now this is important because we find out what the hypotenuse is, which is a square root of 5. Now it's going to be positive because all hypotenuse are always positive. So square root of 5. So it means that this is square root of 5 and this is square root of 5. Now one thing I must do with this is rationalize it. Can't leave a square root as a denominator. So in order to do that, I'm going to do square root of 5, square root of 5. Same thing here, square root of 5, square root of 5. Let me erase this because I need space. Erase a little too much. Go ahead and try that again. Be a little bit more careful. And in this case, let's go ahead and actually finish the rationalization of this. All right, now this is going to be 2 square root of 5 over 5. Square roots cancel out. Same thing happens here, except that this becomes negative square root of 5 over 5. Okay, so I got my 3 values. Actually, let me undo that. I want to make sure that I encompass the negative that's there. Negative here and this. Okay, now I'm actually able to now apply all 3 of my different identities here. First one being sine alpha minus beta. You bring out your green sheet and you look for the identity that is in reference to that. So sine alpha minus beta is going to be sine alpha times cosine beta minus cosine alpha times sine beta. All right, so let's go ahead and fill in some values that we need. Sine alpha, it's right over there, 12 over 13. That's actually what's given to us. Cosine beta, 2 square root of 5 over 13 over 5. So let me go ahead and fix that. So 5 minus cosine alpha. Cosine alpha is negative 5 over 13. And sine beta. Sine beta is negative square root of 5 over 5. Okay, now let's go ahead and simplify this. What I mean is that when you're dealing with this, with 2 fractions, okay, now first of all, y'all see the 2 negatives over here on the right side? Those are become both positives. When you deal with fractions, you can multiply across. So I'm going to multiply those two. 24 square root of 5. And I'll multiply those two. It's going to become 65. That's going to be subtracted by 5 times the square root of 5, which is 5 square root of 5 over 65. Now with this one, they have a common denominator, which means that I could go ahead and add them both. And one thing in particular with this one, let me highlight it. If you have these terms the same, the radicals, if they're the same, you're able to combine them. It is unique in this case, so we're able to do that, but this becomes 19 square root of 5 over 65 as your answer. So with this one, A is going to be that answer. 19 square root of 5 over 65. Can't be reduced anymore. Now I'm going to extend the page, and I'm going to do the answers right below this, because the next thing we're going to do is now, let's see, we're going to do cosine alpha plus beta. So let's extend the page again. Cosine alpha plus beta. I pull out my green sheet, identify the identity, and I find out that my identity is cosine alpha, cosine beta, minus minus sine alpha, sine beta. Okay, great. Let's go ahead and find out what these values are. Let's see. Cosine alpha was negative 5 times 13. Cosine beta was 2 square root of 5 over 5. minus sine alpha. I think that was the 12, 13 that we originally were given. Yeah. And sine beta. Sine beta being negative square root of 5 over 5. Okay, good. Let's go ahead and apply this as well. Remember, as far as this part right here, these multiply. It's going to give me negative 10 square root of 5. And 13 times 5, you get a 65. Minus. In this case, I'm going to do 12 times square root of 5, which is negative 12 square root of 5. And 65 is the denominator again for multiplying 13 and 5. Now these two negatives make a positive. And again, the same thing approaches in this one, or same thing occurs. We have the same radical, same denominator, which means that we could go ahead and just add them together. So 65 we'll have there. This is going to become 2 square root of 5. So that's my answer for that one. Okay, very last one I have to do now is C. C is asking me for tangent alpha minus beta. So tangent alpha minus beta. So I'm going to look at tangent alpha minus beta, and I'm going to bring out the identity property by looking at the green sheet again. In this case, it's tangent alpha minus, write that down like this, tangent beta divided by 1 plus tangent alpha times tan beta. Okay, lovely. So let's go ahead and find out where my tan alpha and beta were. I think the first one was given. Oh, it's hurting the eyes. Okay, negative 1/2. So tangent beta is negative 1/2. So I'm going to go ahead and start filling some of this in. This is going to be minus negative 1/2. And I'm going to have 1 plus negative 1/2. What I'm missing so far is, what is this? The tan alpha. My tan alpha was 12 divided by negative 5. So 12 divided by 1, 5, 12 divided by, I'll just put the negative somewhere in there. All right, so what must we do in this one? Well, two things. We first have to get the numerators to become one fraction. These are both positive. And I'm going to do that by multiplying top and bottom by 2, like this, 2 over 2. And on this side, 5 over 5. The reason why I want that to happen is because as a numerator, I'll get negative 24 over 10 plus 5 over 10. Okay. And now I have an actual common denominator, and I could go ahead and add those together. So I'll do that in the next step. So I want to go ahead and also do this over here. Now this over here, these two negatives are going to become positive, and they're going to multiply across. So 12 times 1, 12, 5 times 2, 10. Okay, let's go ahead and make this a bit prettier. As a numerator, you could just add them. This is going to become negative 19 over 10 when I go ahead and combine these two numerators. Now on this side over here, I'm going to have to get a common denominator, so I will multiply this by top and bottom by 10. Or virtually, this is the same thing as 10 divided by 10. So, and the reason why I make it into that is because, and the reason why that is that this is really the fraction. You can multiply 10 on top, 10 on bottom. So, but the reason why I need that is because I want to get a common denominator there, because I want to achieve this, 22 over 10. Now, from here, I'm going to go ahead and apply, I'm going to multiply the numerator by the reciprocal of the denominator, because that's what happens. And these cancel out, and I'm left with negative 19 over 22 as the answer. So because of that, then that means this is negative 19 over 22. And my B, which I had here, was 2 square root of 5 over 65. So there goes ahead, and we solved problem 1 of the review. Let's go ahead and continue, and now look at the next problem. Next problem on the next page. Okay, here we go. Now we're going to be dealing with half angles, double angles, double angles and half angles. I just said both. Now, in this case, we the biggest thing you need to do in order to achieve, to get the answer to this, assignment 11 covered this heavily, and where you have to also find out what is cosine theta, which in this case is going to be adjacent over hypotenuse. You have to figure out what tan theta is too. In this case, it's opposite over adjacent. What have you been given so far? You've been given sine theta, which is equal to opposite over hypotenuse, and you know that this is 7 over 13, which means that opposite already is 7, hypotenuse already know is 13. What is unknown is the adjacent. And for that, we're going to use this part of the information to draw a unit circle and come up with the actual hypotenuse with the correct side. Now this is going to be pi divided by 2, which is here, and then pi, so which means that this lies in this quadrant. Now there is something important we got to keep in mind, that when you draw this, okay, this is going to be 7, this is going to be 13. Whatever value goes in here needs to be a negative. Okay, so let's go ahead and find out what goes there. Leg squared plus leg squared is equal to hypotenuse squared. 49 plus b squared is equal to 169. We subtract 49 on both sides. We end up finding out we have a b squared equal to, in this case, I'll get 0, 120. So we're going to take the square root of 120. Now, when I take the square root of 120, a couple of things are going to happen right here. I could actually take the square, first of all, this is plus or minus, so it's going to be minus. But the square root of 120 could be broken up into different parts. What do I mean specifically? Okay, if I go ahead, I could go ahead and say this is 10 times 12. Well, not 10. Actually, I could say that, but 10 is actually what I was not looking for. I'm looking for this. I'm looking into saying, okay, we have 4 times 30. Okay, and the reason why I'm bringing that the way I am is because I'm going to simplify this a little bit more. The square root of 120 becomes then times square root of 30, which means that you have negative 2 square root of 30. So, and the reason why that's important is because this is more of a reduced form of radical. Now, you're going to apply this, remember this is my adjacent side. I still need to apply that over here. So this is negative 2 square root of 30, negative 2 square root of 30. Now you need to ask yourself, can the square root of 30 be simplified even more? Well, you start looking at the factors. 30 has just 5 and 6, 2 and 15. So I really don't see 3 and 10. None of those can square root anymore. But for the tangent side, for this one, we do need to rationalize this. So we're going to multiply this by 2 square root of 30, 2 square root of 30. And this is what happens with this. As a numerator, 7 times, this is going to become 14 square root of 30. But as a denominator, you'll be left with negative 4 times 30, which means that this is really then 14 square root of 30 over 120. I'll put the negative, you can move the negative numerator or denominator in this case, but it needs to remain negative. Now 14 over 120 could actually be reduced. And if 14 over 120 could be reduced, we're actually going to put down then, I have my calculator right here. Let's find out what it is. But before I do that, just let me make sure I got the right pointer selection. 14 divided by 120, math frac, 7 over 160. So 7 over 60. So which means that you can reduce this to negative 7 square root of 30 over 60. All right, and this is really what you're going to be looking at when you're applying this one, when you're applying tangent. So I have cosine, and also I have sine. Okay, so now from there, all you really need to do is apply the angles, the double angle formulas. You have all 3 parts to be able to apply all four of these components. This one, this one, this one, and this one. If you want, I'll go ahead and do one of them for y'all. Let me do like, let's say C. The reason I'm doing one is because I'm starting to run a little bit out of time here. So I'm going to just do C because I just wanted to practice probably one of the half angles, which is a little bit more of a, that's sine theta divided by 2. All right, so sine theta divided by 2 is going to be equal to plus or minus the square root of 1 minus cosine theta all over 2. All right, so let's go ahead and actually do this. Now, first of all, we need to think about how theta 2 applies into this quadrant right here. And to do that, I'm going to make this theta 2, but I need to do that, I need to divide everything by 2. So this really becomes 4, and pi divided by 4 is actually right over here, actually. So this becomes this quadrant right here. So if I get that quadrant right there, all that is positive, which means that this sine theta will be positive, nothing negative with it. Now, once I have that out of the way, I could go ahead now and apply. I have cosine theta. I found that out earlier. Cosine theta was negative 2 square root of 30 over 13. 2 square root of 30 over 13. Okay. Divided by 2. Now I want to get rid of this 13. This is going to be my highlight of my focus I'm going to start from. So it means that I'm going to go ahead and multiply top by 13, bottom by 13, because what I'm going to do is distribute this 13. 13 is going to come here and cancel out that 13. So this is going to be my answer at the end. Let me erase some things here. The reason being is I want to make sure I have enough space. Yeah. So let's go ahead and actually write down. I'm going to have the square root 13. These two negatives make a positive. Plus 2 square root of 30 over 26. Okay, what do I do from here? I'll go ahead and break up the square root. So if you bear with me for a second, I'm actually going to write over these solutions because I don't want you to lose sight of what's there. Square root of 26. I can't keep that as a square root, so I'm going to multiply top and bottom by square root of 26. Which means I get square root of 13 plus 2 square root of 30. Now I'm going to put on here 20 square root of 20, actually just 26 like this. And the reason being is because I combine both of these. Just the way I was able to split them up, I also can put them back together. But what's going to happen is that this 26 are going to multiply to both of these. So your answer is actually going to be somewhat of a large, not a large number, but a little bit larger than you're used to. And let me tell you what it is. It's going to be, let's see. Let's go back. So I could go ahead and do 13. Okay, it says right there, 13 times 26. That's the number I was trying to multiply. 13 times 26, 338. Which means that I'm going to have the square, oh, I'm right. Well, I don't want to write anymore. 338. 338 plus 52, which is 2 times 26, square root of 30. And that's all the square root, over 26. So this will be the answer for C. And let me go ahead and shift over to the other problems just because I'm starting to run short on time. So, all right. Hey, good morning. Let's go ahead and start solving 3. Now with question 3, we're going to go ahead and first thing, now the thing that how these are different from the other problems is you're given the information, so they're a lot simpler. You're verifying when pi divided by 3 minus pi divided by 3 is going to be. And we got to go ahead and start with the formula. And I'll erase this. Well, I won't erase that, but what I'll do is that I'll go ahead and write sine alpha cosine. I'll write the equation down. This is going to be important, and we're going to have the benefit then of just verifying the values, and then we'll go ahead and just prove it. Now, this is sine of 0, and 0 degrees or 0 radians, however you want to think about it. Actually, in this case, it'll be radians, so think about it as radians. Now, when you look at the unit circle, and you look when it's 0, the sine value meaning y guarantees me that this value over here then is going to be just 0. So what we're going to do over here is verify that. Now, every time you see alpha and beta, you're going to put that in. So sine of pi over 3, cosine of pi over 3, minus cosine of pi over 3, sine pi over 3. And what we're going to do from here is that we'll discover what each of these values are. So pi over 3, I had to know what cosine and sine of pi over 3 are. So we have 1/2 and square root of 3 over 2. So in this case, this is square root of 3 over 2. This is 1/2. We're going to be multiplying these two. And then the same thing over here, except that it's kind of like in reverse. Square root of 3 over 2. And when you get the solutions to these, this is just square root of 3 over 4, because remember this numerator, and this part in denominator, same thing here. And this comes out being 0, and this is how you prove it. So that's for A. Let's go ahead and now discover how to, let's do B and tangent. All right, so let's go ahead and now discover B. Now the formula for B, slightly different, but the same thing. In this case, we're going to discover what cosine of pi over 3 are, plus pi over 3. And when we do that, when we add these two angles, we're going to be using the equation. It has to do with the cosine alpha, cosine beta, cosine beta. Let's fix this and write down cosine beta. And then we're going to do minus sine alpha, sine beta. Now here on the, let's start with the left side. This is really 1 and 1 in there. So this results as 2 pi divided by 3. And then from there let's look at the unit circle. 2 pi over 3 is right here, and we discovered that the cosine value is going to be negative 1/2. So when we're proving this, we should be getting negative 1/2 as a solution. But let's go ahead and discover that's true. Cosine of pi over 3, cosine of pi over 3, minus sine of pi over 3, sine of pi over 3. Now we had discovered what these values were from before, and we found out that cosine is just 1/2 and 1/2. So we're going to multiply these two, and then we're going to multiply that with the square root of 3 divided by 2, square root of 3 divided by 2. So this comes out being 1/4. This comes out being, remember, square root 3 squared times square root of 3 is just 3. 2 times 2 is just 4. We have a common denominator, negative 2 over 4. And this reduces to negative 1/2. So the very last, we went ahead and proved that negative 1/2 is equal to negative 1/2. So this is how you're going to go ahead and write down your proof. So this proves our solution, the one we came up with. All right, now let's go ahead and now look at C and discover what C does. And do the same proof. All right, so in this case, the last one, tangent. Okay, so let's go ahead and do C. Now with C, it's going to want tangent alpha. So in this case, pi over 3 minus pi over 3 as well. But the equation for this one, for tangent minus, is tangent alpha minus tangent beta, 1 plus tangent alpha times tangent beta. Okay, let's go ahead and discover some of these solutions. So we know this is going to be tangent of 0. And let's go ahead and find out what that is. Tangent of 0 is 0. So we're going to prove that this is going to be 0. So let's go ahead and write down the formula. Or let's just go, I'm going to make it a little bit easier so you'll see what's happening. Directly, here, 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 and here, we're going to put in pi over 3. So we're going to write down the solution. pi over 3, pi over 3, pi over 3, and pi over 3. Now it's important for us to get the value of what pi over 3 is, especially we have so many here. And actually, the reason why this is going to be 0, or how it's going to get proved, is simply when I look at the value of pi over 3, you see how we have square root of 3? All right, one of the things we're going to do is that we're going to come right over here, and we're going to write down square root of 3 minus square root of 3. And technically, it will be 1 plus square root of 3 times square root of 3. But no matter what, the thing that comes out important is that this is going to be 0, this is going to be a number, the result is 0. So it's important to go ahead and just discover. Once we make that discovery, it's not necessarily going through the whole process of figuring out the denominator. We went ahead and proved that that is actually 0. All right. Now, I love it. Let's move to question 4. So let's see. Question 4 is pretty much the same thing, but you're going to be verifying with different values. So I'll do one of them, one of the proofs. Maybe I will do all 3. Let's go ahead and see. All right, so in this case, we're going to go ahead and find out what sine 2 pi over 3 is, minus pi over 6. And this one's a little bit more involved because we got to get a common denominator. So I'm going to multiply 2 top and bottom, and this produces the solution 4 pi over 6 minus pi over 6. And then the result of this comes out being sine of 3 pi over 6. And the solution to the reduction of that comes out being pi over 2. So sine of pi over 2, you look at the unit circle. Let's pull it up, come on. Sine, it's just 1/2. Oh, didn't want that to happen. I mean, no, not 1/2, it's 1. Of pi over 2. So one of the things we're going to prove with this one is that when we discover the process behind this one, I'm going to move this up a little bit. We want to prove that all this is 1. So we're going to start with the equation again. Sine alpha cosine beta minus cosine alpha sine beta. Now this time we're going to have different values, so it's going to be important for us to put 2 pi over 3 and cosine of pi over 6. The next result is going to be the cosine of 2 pi over 3. And then we're going to also look for the solution of sine of pi over 6. All right, so let's discover these values. Now when I bring up the circle, 2 pi over 3, cosine is going to be negative 1/2. So this is going to be negative 1/2. Cosine of pi over 6, let's bring up the unit circle. Pi over 6 is over to my right, square root of 3 over 2. So it's going to be square root of 3 over 2. And after that, cosine of 2 pi over 3, let's go. Oh, actually, I might have done this wrong right here. The sine of 2 pi over 3. Let's look at it. Yeah, it should have been square root of 3 over 2. Right here. This would have been negative 1/2 cosine of 2 pi over 3. And the sine of pi over 6 is 1/2. Okay. All right, so let's go ahead and solve this. Now, square root of 3 times square root of 3 is just 3. 2 times 2 is 4. Minus, this is going to be positive because of these two negatives right here. This is going to be 1/2. I'm sorry, not 1/2, 1/4. Because 2 times 2 makes a 4. Once we discover that, then we get the solution 4 over 4. So we get 1 here. So this is how we go ahead and prove A on this one. Then we do the process, we go ahead and actually discover that as a solution. All right, let's go ahead and continue to, well, B is going to be similar, and so will tangent. So you just have to kind of just follow the equations. These are both similar. I would love to kind of get through and do 5 and 6 with you in the back, so you get the benefit of seeing those. So let's, or let me go ahead and continue with this, because I could always, what I was trying to do is I was trying to see if I could get it all done in this time frame that I had. I'll probably just pause it and just pick it up where I had it from. All right, so now let's go ahead and discover what B is. All right, so B has it that we're going to be discovering what I think it's cosine minus alpha. No, cosine plus. Okay, so we're going to go ahead and find out when we take this angle, 2 pi over 3, and add it with pi over 6, what the solution comes out being. So we're going to discover the result of what cosine alpha is times cosine beta minus sine alpha is times sine beta. All right, so let's, now over here, let's start over here. Same thing, 2 over 2. We'll get a common denominator, 4 pi over 6. We'll add these two fractions, and we'll end up with, we'll look for the 5 pi, the solution for 5 pi over 6. So let's look at the unit circle and see what that is. 5 pi over 6, I believe it's over here in quadrant 3, so let me move this a little bit. See if I'm going to scroll. Here we go. 5 pi over 6. Oh, there it is. Okay. So 5 pi over 6 is right over here. And the cosine line is going to be negative square root of 3 over 2. So we're going to try to prove, or one of the things we're going to prove is discover on the right, this is going to be the solution. It's negative square root of 3 over 2. So we're doing cosine of 2 pi over 3, cosine of pi over 6, minus sine of 2 pi over 3, sine of pi over 6. Now, I know some of these values are right because remember the cosine of this one was negative 1/2. This one was square root of 3 over 2. And if you want to verify these solutions, like prove to yourself that these are guaranteed, look at the unit circle. And you could discover those as well for yourself. This was square root of 3 over 2. And this one was 1/2. Okay, so this is what it comes out being. We're going to go ahead and receive, well, just let me double check myself. Cosine 2 pi over 3, sine, yes, okay. And so when we add these, we're going to go ahead and get negative square root of 3 over 4 minus negative square root of 3 over 4. So this comes out being negative 2 square root of 3 over 4. And this is reduces to just 1/2. So negative square root of 3 over 2. So from here, we're able to prove that this is true. So you're going to have to perform these operations so you can prove your solutions on these. All right, so now let's go move forward. And let's do C. All right, so for C, it's tangent. We're going to do the 2 pi, so alpha minus beta. Okay, same thing, 2 over 2. We discovered that this is still 4 pi over 6, but we're going to be subtracting pi over 6. So once we do that, it comes out to the conclusion that it's 3 pi over 6, which means we're going to be looking at the tangent of pi over 2. Oh, very interesting. This proof is going to be a little bit new in the sense because we really don't cover this a lot, but when we look at the tangent value of pi over 2, we discover it's undefined, which means that I should be expecting when I'm solving this one, this is undefined as a result. I should be expecting on this one when I start doing my equation, tangent of 2 pi over 3 minus tangent of pi over 6, that my denominator, this undefined, is going to give me an indication that my denominator should be 0. Because that's the only time you actually hit an undefined. 1 plus tangent of 2 pi over 3, tangent of pi over 6. So what I'm going to do is I'm going to focus on the denominator in this case. Because I'm kind of expecting that this is going to happen. So what I'm going to do is just look for the values of tangent of 2 pi over 3 on the unit circle. Negative square root of 3. So that means that this is going to be 1 plus negative square root of 3. And tangent of pi over 6, square root of 3 over 3. So this is going to be the value square root of 3 over 3. So now let's go ahead and discover, I'm just going to work out the denominator for right now, because this is going to multiply with that and make negative 3 over 3. And there it is. This is really 1. 1 minus 1, which makes it 0. And this is how you prove undefined. So undefined. And this is how you get that result. So we go ahead and write down our proof, and we went ahead and discovered the solutions for A, B, and C. Okay. Now let's move forward with question number 5 and see. Let's start solving that one. Now this one wants us to verify double angles for cosine, sine, and then half angles. So let's go ahead and start with this one. We'll do the double angle formula, and like sine. This is how you do the verification. Oh, for one thing though, this is important, and I'm probably going to be telling for A and B, you will not be using these values. Okay, so I'm going to have to make that correction in class as well. What I need you to do is just strictly use this value, because it's going to be important that we just use theta. So in this case, we're going to go ahead and discover what, prove this. We take that angle, we double it. We're going to go use the formula 2 sine theta cosine theta. And this is one of the things we'll end up with. We're going to discover what sine of 2 pi over 3 is. Since I was looking at this value so much, I know what it is by heart right now. Square root of 3 over 2. So that's what we want to prove over here. So this is going to end us, then as we continue proving this, we'll have sine of pi over 3, cosine of pi over 3. We know that when you look at the unit circle, sine of pi over 3 comes out being square root of 3 over 2. Cosine of pi over 3 is 1/2. So now this is going to be important. It's I placed a denominator because I'm going to take 2, multiply with the square root of 3, multiply by 1. So we'll get 2 square root of 3. So you know exactly that only the 2 multiplies with the denominators on the other 2 fractions. And then we'll have 4 down here. And this right here reduces to square root of 3 over 2. And this is how you prove A. Okay. All right, now I'm going to erase this so we can focus on B next. And let's discover what solution to B is. Now B, you have a couple options. You use a couple of different equations. I'll use just now the same thing. So we're going to figure out what cosine of 2 pi over 3 is. Or we're going to be doubling this angle. So this is going to be then just 2 pi over 3. Since we're looking at this value as negative 1/2. Now the equation I'm going to decide to use is going to be 1 minus 2 sine square theta. It really doesn't matter which one you use, just as important as you use one of them. So in this case, we're going to do 1 minus 2 times sine of pi over 3. Now this is going to be a little new because you're not used to really taking that square and putting it on the outside and then figure out what the value of sine of pi over 3 is. In this case, it was 1 minus 2. And sine of pi over 3 is square root of 3 over 2. We're going to take that value and square it. So this is, remember, it's very important you follow the order of PIMDAS. Some people are tempted to do the 1 minus 2 and then start doing it because they're so used to working from left to right. Please do not fall in the trap. Follow PIMDAS. Trust it. Remember, I'll separate so you can see what's going on here. And you have a better sense of the discovery of the solution. And together, square root of 3 times square root of 3 comes out being 3. 2 times 2 is 4. So I'll continue holding that minus until the very end. Remember, this is important. You're going to do 2 times 3, which is 6 over 4. This reduces, well, we don't have to necessarily reduce it. We can make it, we do need a common denominator. So I made this 4 over 4. I multiply 4 top and bottom. We get negative 2 over 4. And this is how we get negative 1/2. So since I have negative 1/2 here, negative 1/2 here, you go ahead and prove it. So at the very end, you do want to write negative 1/2 equal to negative 1/2 with showing the work that you did the proof. All right, lovely. Let's go ahead and move on to the half angles. And I'm going to do with the half angles. Let's just use the half angle formula. So we're going to go ahead and do sine. In this case, it's going to be pi over 3 divided by 2. Okay, now when you do this, one of the things you discover is that we got to multiply by the reciprocal. Now this is 2 over 1, so this is going to be 1/2. So we're really looking for when sine of pi over 6 is. Now one of the things we discover is that when we look at the unit circle, sine of pi over 6 is 1/2. So we want this to be 1/2. Alright, so let's get our half angle formula. Now since this is important, because remember we learned all students take calculus. Quadrant 1 means that all trig functions, this is going to be in quadrant 1, all these are going to be the positive version. So we're going to use positive square root of 1 minus cosine theta divided by 2. Now in this case, we're going to be using directly this value right in here. So we're going to be using cosine of pi over 3 divided by 2. We know that this is going to be 1 minus square root of 3 divided by 2 divided by 2. So, no, that's actually not correct. I should have looked at the unit circle. Let's fix this. This is really 1/2. So I'm going to make this into a common denominator, so I'm going to make this into 2 over 2. And multiply 2 top and bottom. And then we'll discover that it's 1/2 divided by 2. I'm going to accentuate this with a 1 there. And let's see, that's cosine of pi over 3. Cosine of 1/2. Oh, yes. This is going to be then 1/2 times 1/2. Oops. Which comes out being 1/4. Square root 1 over square root of 4 becomes 1 over 1/2. Because the square root of 1 is 1, and the solution of square root of 4 is 2. Okay. All right, good. Now let's, so we get 1/2 as the proof here. All right, great. Now let's do our, not the last one, but let's go ahead and work on D. D is going to ask for the cosine of the same thing, except that instead of sine, we're looking at cosine. So let's, now this whole thing about all students take calculus still holds true. So it's important that you still remember that. But let's move forward with now the discovery of what this comes out being. So we're going to go ahead and do cosine of pi divided by 3 divided by 2. Kind of like the same thing before. Accentuate this because one of the things that's going to happen is going to be pi over 3 times 1/2. So we're looking for a cosine of pi over 6. And I know that cosine of pi over 6 is square root of 3 over 2. Again, you can get the solution by looking at the unit circle. All right, now one of the things I love is that with this one, we're going to do positive square root 1 plus cosine of pi over 3 divided by 2. And from here, we discovered that this is now positive 1/2 divided by 2. It's going to be 2 over 2. All I did is get a common denominator, so I kind of took away the 1. Or let me kind of take this in slow motion with you. This is 1. I did 1 over 1. I'm multiplying by 2 over 2. It's equivalent. And I'm going to erase and just put 2 over 2 in that spot. And then we'll take numerator plus numerator, so it will come out being 3 over 2 divided by 2. Again, I'm going to accentuate the 1 here because it's going to be important that when we take the square root of this, this will be 3 over 2 times 1/2, which comes out being the solution of square root of 3 over 4. We're going to break this up into numerator and denominator. You always do this with half angles. Oops, 4. And fix that. So it'll be 4. And then after that, we'll end up with the solution of square root of 3 over 2. So we do verify that we get the square root of 3 over 2. All right, lovely. Let's move on to the very last one. Okay, now on the very last one, we're going to be verifying this. We're going to be verifying just A and B, so just double angles. Now, the thing that's important to keep in mind about this one, that this right here is the value of cosine. So the cosine of the angle, in this case, is 3/5, and this one is sine. So the sine of the angle is equal to 4/5. That's the two guarantees that we have. So one of the things we're going to go ahead and prove when we want to find out what the cosine of the double angle is going to be, so in this case, the double angle, we're going to use these two values to figure out what this angle is going to happen when we double it. Now, let's go ahead and start with the formula. In this case, well, actually, cosine is b. So let's erase this. We're going to go ahead and start with sine. And we're going to go ahead and take this one and do sine of this time double angling. And this is going to be then the result of 2 sine theta cosine theta. And from this, we'll get 2 sine, oops, not sine. Since we know that that equals that, this is just going to be the solution of 4/5 times cosine theta, which is 3/5. This is 2 over 1. Now, I remember, I'd make the result 2 over 1 to kind of accentuate 2 times 4, 2 times 3. So this is going to be 8 times 3, which comes out being the solution 24. 1 times 5 is 25. So the new result is that when you take the cosine and you double angle it, you get the solution 24 over 25. All right, great. Let's move on to B. B is something similar. Again, you could use whatever formula. There's 3 formulas with doubling cosine. I'm going to go ahead and use the one that is just 1 minus. I'm going to switch it up this time. If you want, I'll use the one that sometimes it's very commonly used is the cosine squared theta minus sine squared theta. I'm running out of space there. If you want, let me rewrite it over here. Okay, so B, we're going to do cosine double angle. And that's going to be then cosine squared theta minus sine squared theta. So we're going to go ahead and use then this kind 3/5 squared minus 4/5 squared, because those are the values for each one of those. And from here, this is then going to be 9 over 25 minus 16 over 25. So what we discover from this, 9 minus 16, I love the fact that a lot of these double or double angles, you get a common denominator automatically. So I'm going to take 9 and subtract it with 16 and get negative 7 over 25 as a solution. So that's when we end up getting. I would also kind of just roughly, as practice on the exam, it's also going to ask you for C and D on these, to actually perform these doing C and D. So taking these angles and doing a half angle to them. And you're going to be asked then to actually take this result. Like if you want, I'll do C with you. Even though it doesn't say in the instructions, there should be C and D on here too. So remember, this angle is in quadrant 1, so we can use the positive version. But in this case, we're going to do positive square root of 1 minus cosine theta divided by 2, which means that we're going to do the square root of 1 minus 4/5. Yes, no, 3/5. It's going to be 3/5 on all these half angles. This is 5 over 5. It's the common denominator. So this comes out being then 2 over 5 divided by 2. And then this solution comes out being then the square root of, I'm going to accentuate the denominator as being a fraction. So when I combine the fractions, I know what's happening. Now we discovered that these cancel out. So we actually get the square root of 1 over 5. And then we're going to break this up. It's going to be the square root of 1 over the square root of 5. We have to rationalize this. So square root of 5 times the square root of 5. Now, I love the fact that in the denominator, most of you can look at the square root of 5 times the square root of 5 and get 5. For those that are wondering why this is happening, if you have two square roots, you have the power to take remember on the inside, multiply them together, like 5 times 5, and get 25, and that's how we end up 5. But the solution on this is going to be the square root of 5 over 5. Now let's go ahead and then move forward to the next one, which is D, and that'll be the last one on this case. Now D is going to be very similar in nature, other than the fact that we're going to be half angling cosine. And when we do the half angle of cosine, the only difference is that the equation is 1 plus cosine theta. I love the fact that we proved that in class with the notes. And this is 1 plus, in this case will be 3/5 divided by 2. You're going to get a common denominator here, which would be 5 over 5. And then this is going to be the square root of 8 over 5 divided by 2. We're going to accentuate this as a fraction because I'm going to combine it. It's going to be 8/5 times 1/2. I'll notice a reduction in here. So this solution, 8 over 2, comes out being then 4 over 5, basically, times 1 over 1, which is really just 4 over 5. I'm going to split this up. Square root of 4 over the square root of 5. Separate numerator and denominator. That's going to be important. And this comes out being 2 over the square root of 5. Then I'll multiply square root of 5 over the square root of 5 to rationalize it. And the thing that we'll discover is that this becomes then 2 square root of 5 over 5 is the solution. And that'll be the solution for the half angle. All right, one of the things I would love for y'all to do is go ahead when you're working on this. You saw this video. You need to try to make sure you understand all this. So rewrite the problem. See if you're working on your own. Remember, in order to be successful in the test, you got to be able to at least be able to remember, understand, and then apply as a minimum. And the only way you can get here is by testing yourself. You have to be able to show, can you do this on your own without looking at this video? All right, good luck on the exam.